So this is the course content we have. So I have sent you the course content already, so you can just check with that.
Yeah, sure.
Right. We gone through all these stuff. So we are here actually now. So you're able to see my screen, right?
Yeah, I'm able to see the screen.
So independent link layers. So how these layers are formed? They are all independent layers, but they are linked together so that together. So that is the way it's been designed. So three layers are there. So one layer is what the outer layer, and you have all these services. So these services are managed and it's been residing in Snowflake. Okay. So where all of these services will be enabled all the time, and it will be collecting information about your data. That is, the metadata information is being collected, and as well as it will provide you those information to the users. So whenever you require, right? So something like, for example, if you want to create some users, so you want to do some access control, so that can be done by this particular layer. And if you want to do some sharing, data sharing, and if you want to implement the security, so all these optimization, so everything else other than data related, so these layers will, this layer will provide you these services which are all related with metadata. Okay, so that is what this layer is about. The next layer is actual compute. So your SQL data engine resides here. So where you will be able to run a query, execute a query. So any type of query you want to execute, so you want to load data, or you want to put a select statement, so where you can do some analysis over there. So everything else can be done over here. Okay, so that is what the next layer, we call it as compute layer. The third one is the storage layer, where all your data is being residing, right? So whatever data you are loading, so all those data will be residing out here. So that is what the third layer, storage layer, is about. So Snowflake, the entire Snowflake is made up of these three layers. Okay. So that's the way it's been designed. So let us just check here. Scaling and elasticity. What do you mean by scaling? Scaling is, we know that. So we need to, sometimes we need to increase the capacity of the system. So whenever you want higher capacity system is to be implemented. So when you will be having a larger query is going to be executed, or when you want to accommodate more users so that they will be using parallel processing. So that time we need to scale up our compute systems. So that is what scaling is about. So elasticity is whenever you are scaling up, so that will be made like it can accommodate more users, or it can capable of executing a very large amount of data. Then after that, your requirement is over and you want to go back to your previous state. So that is what the elasticity is about, right? So you can expand it and you can just shrink it at any point of time. Right? Both your storage, compute, so both of them can be expanded at any point of time and it can be shrunk at any point of time independently. Right? So that is what the scaling and elasticity is about. What are the services you are having here? Right? So the first layer we talked about what services you are having here. So the services are the brain of the Snowflake architecture, because whenever you are accessing a Snowflake account, your account, so you are going into these services only. So anything you reach through these services only. So whether you want to invoke your compute, whether you want to reach your storage to get some data from that, everything through these services only you can go inside, right? So authenticate user sessions. So when you start working on Snowflake, it means that you are working under one session. So when you can create multiple user sessions, right? So these user sessions are authenticated initially, by these services, and it can provide management of your service and data. Then it can enforce some security functions. So whenever you are working on data, so how the data has to be encrypted, or how the data can be transferred with secure transferring, and how the data can be accessed. So everything else, all these functions are enforced here only. And the query compilation and optimization. So whenever you are executing a query, so where this query has to be taken, how the cache management has to be done, and how much amount of memory to be used, right? So all of them are being it has to be finalized here itself, right? So that is what they call this as a brain of Snowflake architecture. So then coordinate to all the transactions, whatever transactions you are carrying over here. So in the Snowflake, so everything it get coordinated here itself, right? Then it is used to construct the status compute resources, which runs across multiple availability zones. So what do you mean by availability zone? So if you are familiar with clouds, you will be knowing about. So whenever you are storing data, the data is being stored in one location normally, right? But in the background, it is available in other zones also, so that you will be having a seamless connection all the time, right? So the end user, if one location, that means if you are loading it in one location, actually it will be loaded into three availability zones. So if any one of the zone is not available for some reasons, the connectivity you have lost for one zone, immediately without any delay for the very, very small milliseconds of time will be there. It will be connected with another availability zone immediately, right? So that is the way it works. So that will be managed by these services, right? So the security and encryption, key management, so everything else apart from storage and the execution of query, all the other services will be available here. Okay, so I hope you understand this. The layer is compute. Yeah, next layer is compute. So where you will be executing, just it is comparable to your CPU, right? So where you have the CPU along with some RAM. So these two combinedly together forms this layer, right? The query processing takes place here. So whenever you are executing a query, so for any purpose, so you want to load data, you want to do some select statements, or whatever, only two of these, if you are going to load data or you want to extract some data. So both of them can take place here. So it can be performed with multiple clusters also, right? So you can create some compute system. Here we call this as virtual warehouses, right? Or simply warehouse. So don't confuse with the data warehouse and this warehouse. So this warehouse means it is a computer. Okay, you can just keep it as a computer. So this virtual warehouse, Snowflake call it as virtual warehouse. So these are all formed with multiple clusters also. So you can have a cluster of computers. So I'll explain them later on in a more detailed manner. Okay. So it is only the minimum data required from storage layer to satisfy. So you can analyze your query, which is based on the services will be passing on the designing of the query execution, right? So you will be having an execution plan. So that will be made by the services, and it can get only the data which is required for your query. And it is possible to cache the query locally. So the results of the query can be cached locally, right? So they will be smartly finding out so what data available in your what data available in the result set, and how much of data can be cached here, and how much of data can be reused. So that way they can just create this cache memory. The cache memory is already there. They will create a plan for storing the data, and it will be stored under the cache memory. Right? Same manner, you can operate multiple virtual warehouses simultaneously. So in the same data, because these are all independent layers, so what you can do is you can operate multiple virtual warehouses. So one warehouse for loading data into a database, and another warehouse for doing analysis on the same database, right? So like that, you can split your workload across multiple warehouses. Okay. The last one is storage. So the storage is built on cloud blob storage. So blob storage you'll be knowing about. So very large object, right? Binary large object. So where you will be able to store any type of data over there, right? So any type of data you can store. So any diverse data. It can hold tables, it can hold query results also. That diverse data means it's not just tables, it is there. You can load files also, right? So how you can store data in your local system, so like that you can use them to store files, right? Snowflake support files which are all formed in some formats, right? So CSV, JSON is the main formats we have. We have other formats also. We'll be seeing that. Okay. So then it is assured to have the maximum scalability, elasticity, and performance capacity. So whenever you talk about the storage can be scaled at any point of time. Whenever you want to store huge data, you don't need to enable or you don't need to configure anything. Just store data, it will be expanded automatically and will occupy the data can be occupied into the storage. Right? Similarly, you can use for data warehousing and analytics, and this is engineered to scale completely independent of the compute resources. So you don't need to worry about how much compute resource can handle. Right? So that is a different layer. You may have a compute resource which is very small to handle a huge amount of data. That doesn't matter about when you are storing data. Right? Storing data and the compute, both of them are independent. They can work independently. Right? So the data is stored in micro partitions. So normally in a database, you know that there are partitions in the database. So each of the table can be stored in multiple partitions. To have a better performance, we will be using partitions, right? Here also we use partitions. These are called as micro partitions because the size is comparatively small. So maximum of 16 MB of compressed data, maximum of 500 MB of uncompressed data. So that will be stored in one single partition. Okay. So whenever you are loading data into that one, so you will be having multiple partitions will be created for each table, right? So the partitions can range from 1 to millions of partitions inside, right? So we don't have limitations about that. So I'll be explaining you about how these partitions are created and in what way the Snowflake is storing data so that it can be getting the maximum advantage of this on performance wise, right? So that we will be explaining later on. So just simply you understand that. So data is loaded into partitions only, right? Automatically it will be splitted and it will be loaded into partitions. Metadata is extracted. Whenever you are loading, the metadata also is extracted and it will be kept separately so that without disturbing your actual data, metadata can be accessed. Something like, for example, you want to have a total number of records available in a table. So every time it doesn't need to count the records. So the total number of records will be stored separately. So without going and without reaching the actual data, you can just check what is the total amount of records available in each table, right? Something like that. So the micro partitions are columnar, compressed, and fully encrypted. So these are all columnar storage. So the data is not stored on row wise. Data is stored on column wise. Okay. So that time, whenever you are using a data, so the data is being whenever it is stored, you will be loading the data on row wise only. Normally, we will be loading data row wise. Every row will be loaded one by one, but it will able to split the data on column wise, and every column wise it will be storing the data, okay, internally. So we will see that. So how the data is being stored and all. A little bit of. We'll quickly go through this. So how the architecture is formed and all. Whenever we are going for the performance tuning, so how the data is being stored in detail, you will see that. Okay. So AWS, how they are using, right, Vijay?
Yes, Murli.
So AWS is using a service called S3. You have heard about it. So the S3 is being used here. Okay. Whenever you are creating Snowflake under AWS, the S3 service will be used for storing data. And the EC2, you have heard about EC2, right?
Say to no, I haven't, Murli.
Okay, no problem. So there is a service called EC2, so where you can create virtual systems, virtual computers. Okay, that service is used to compute, right? So just to have an idea, we will be talking more detail later. Okay. So, what are the benefits about Snowflake when we are talking about these things? So, independent storage and compute layer is the one of the benefits here. So, that is why we'll be having a great performance, parallel computing, shared and both not shared. So, both hybrid kind of thing. So, all are possible because of this independent storage and compute layers. Okay. Instantly scalable. Both of them can be instantly scalable independently without disturbing another one. So activity in one warehouse will not affect another warehouse activity. Right? So for example, you are doing some load, data loading is happening. So what happens when you are loading data? Normally in some other databases, so where you are using in on-premises, so that may affect the other users also. So whenever they are executing a query, which a complex query where it involves more kind of aggregation, grouping, sorting, everything is happening together. So that may affect the performance of a query, right? So when a heavy loading is happening. But here it is not the case. So when one values is being assigned for loading data, another values you assign for executing some queries. So both of them can work independently and it won't affect the performance at any point of time. Right? Because the resources what you are using for one values is not been shared with another values. It is all both are independent. So we will be having a seamless way of working, right? That's the thing. So multi-clustering for unlimited concurrency. So what do you mean by multi-clustering? So each of these values can have multiple clusters, right? You can have one single cluster. Cluster you can imagine as a computer, right? So you have a quad core, right? Like that you have octa core, like that you are having processes, right? So you can just imagine something like that. So where you will be having multiple clusters together. So these clusters are used for parallel processing, right? So for example, if you are having some 5 users, for example, I'm telling it is not the real way of measuring the performance. I'm just telling you an example. So when you are having 5 users, maybe one cluster is enough. When you have 10 users, you need to have 2 or 3 clusters, something like that. So when you are adding more and more clusters, what happens? You can handle parallel processing more easily, right? So that is what the capability of this multi-clustering. Then asset integrity across all values. So asset integrity where we will be available for any type of data. Nowadays, they are almost all are having this atomicity, consistency, right? Integrity and so that is the asset integrity for database over there. So that will be always been implemented here across all the values. So they will be